Hi everyone, this is Maverick Hua, the chemistry guru. Now in this video, we want to go through the suggested solution for 2020 A-Levels H2 Chemistry Paper 1 Question 9. Alright, let's take a look at question 9. You have 1.00 gram of boron carbide completely oxidizes to form 2.50 gram of boron oxide B2O3 and 0.80 gram of carbon dioxide. So the question is asking us to determine the empirical formula of boron carbide. So we have four options here, A, B, C, D. Later we will run through the possibility. Now, if I want to work out the empirical formula, basically what I need to determine is, based on the information that we have here, 2.50 gram of boron oxide, 0.80 gram of carbon dioxide. What we want to determine is what is the number of mole of boron inside this sample, and what is the number of mole of carbon inside this sample. Then I can compare mole ratio between them. I can work out the empirical formula, correct? So basically 1 gram of your boron carbide, what is the number of mole of boron, what is the number of mole of carbon, I can compare mole ratio, and I can determine the empirical formula. So the topic tested in this question is actually under mole concept. So let us run through this idea here. I have 1 gram of your boron carbide. We don't know what is X, we don't know what is Y. So let it be BXCY. I know that I have 1 gram of it. So it would undergo oxidation to give me B2O3 and CO2 given. B2O3, I have 2.50 gram of it. And for carbon dioxide, I have 0.80 gram of it. And what you notice is all your boron in your boron carbide will be converted to B2O3. So it means that if I can find the number of mole of boron in this 2.50 gram of B2O3, then I know the total number of mole of boron inside this 1.00 gram of your compound. So very nicely, all the boron go to one product. So it is very easy for me to account for the amount of your B in the question because it only goes to one place. Easier to account for that. Similarly, for my carbon, you notice all this carbon will go to carbon dioxide. So if from 0.80 gram of CO2, I can find how much carbon we have, then that will be the carbon in your original compound. So again, very nicely, all the carbon will go to one place. It's very easy for me to account for that. Now what we can do is we can make use of this formula under mole concept. The mass ratio equals to the molar mass ratio. Now the formula actually looks something like this. In terms of application, the mass of the X that you want to determine divided by the mass of your compound will be equal to the molar mass of X divided by the molar mass of your compound. So the formula actually works on the basis that in a compound, your elements are chemically combined together to form a compound in a fixed ratio. So given any sample, if you have 1 gram of your compound, if you have 10 grams of your compound, or if you have 1 mole of the compound, the ratio of the element to the entire compound, it should be in a fixed ratio. So mass ratio is equal to molar mass ratio. So let's see how we can make use of this expression to work out or to determine the mass of your boron in 2.50 gram of B2O3 and the mass of carbon in 0.80 gram of CO2. The idea is the same, so I have them side by side so that we can see them together. So let us focus on the left hand side first, determining the mass of boron in this sample of your B2O3. So mass ratio equals to molar mass ratio. Mass of B divided by mass of B2O3 equal to molar mass of B divided by molar mass of B2O3. Mass of B is the one that we want to determine. Mass of B2O3, it is given in the question, 2.50 gram. This will be equal to molar mass of B. Now molar mass of B, the atomic mass of boron, we can find this in the periodic table. This is 10.8. Now the reason why I need to double this is because in one sample of B2O3, I actually have 2 boron. So I have to take that into consideration. The molar mass of B will be 2 times the atomic mass of B, because in one B2O3, I have 2 boron. So I need to double that, 10.8 times 2, divided by the molar mass of B2O3, which will just be mass of boron, double, plus the mass of oxygen times 3, correct? 10.8 times 2 plus 16.0 times 3. So what I can do next is I can just bring the 2.5 over to the right hand side, simplify this. I can determine the mass of boron, 0.7759, and I can also determine the number of mole in this sample, will just be 0.7759 divided by the atomic mass, 10.8. I'll get this value, 0.07184. So I now have the number of mole of B inside this 1 gram of BXCY, this boron carbide. Now I can do exactly the same for carbon. In CO2, mass of carbon to mass of CO2 equal to molar mass of carbon to the molar mass of CO2. So mass of carbon is the one that I want to determine. Mass of CO2 is given 0.80. Then molar mass of carbon, of course, will just be 12.0. In 1 carbon dioxide, I only have 1 carbon, so this will just be 12.0 divided by the molar mass of CO2, 12.0 plus 16.0 times 2. Again, I bring the 0.8 over to the right hand side. I can solve for the mass of carbon, 0.2182. Then I can find the number of mole of your carbon, which is 0.2182 divided by 12. Then I'll end up with this 0.01818. So I have now the number of mole of carbon inside this 1 gram of BXCY, your boron carbide. So once I have this ratio, I can simply work out the mole ratio between B to C. What is the mole ratio for boron to carbon? I can substitute all this number of mole inside here, 0.07184 divided by 0.01818. I can get this ratio, of course, round off to the nearest integer, 4 divided by 1. So it means that inside this sample of your boron carbide, I have 4 times more boron than carbon. And the empirical formula for your boron carbide should also reflect that. So in this case, if I consider option D, the empirical formula for boron is B4C, which means that I have 4 boron to every carbon, alright? So which works out very nicely. It tells me that the mole ratio for B to carbon is 4:1. I have 4 times more boron than carbon. So if I run through the options, the answer in this case for the empirical formula for this boron carbide has to be D, B4C. Alright, so that was the discussion involving question 9. So if you have learned something useful from this video, please give me a thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.